Enclosure cooler installation process. The package includes an installation template and installation screws. The installation template is attached to a suitable location on the enclosure. Holes are created with a drill as shown on the template. The air ducts on the template are cut with a jigsaw tool. The installation screws are mounted to the holes on the back of the cooler. The cooler is positioned on the enclosure cover. The panel is fixed by tightening the screws on the cooler with nuts. The drainage nipple inside the package is fixed to the drainage output under the cooler. The drainage hose is fitted at the end of the nipple. The cooler power supply. The energy is supplied with phase neutral and grounding cables from the connectors behind the cooler. The pins 4 and 5 in the connectors are inside the door switch connection. The unit can stop working by connecting a switch here. Pins 6 and 7 are used to create warnings with dry contact when there are any cooler failures. These pins can be used for 220 volt or DC signals. As shown in the example, a lamp can be turned on when there is any failure. The pins 8 and 9 at the end are for RS-485 connection. Here, you can transfer all cooler parameters to the communication system. The installation is completed with these steps. Changing the set temperature. Press and hold the set button for 3 seconds and the set temperature will appear. Then, change the value with the direction buttons. Lastly, press the set button to save the settings. Set bottom lock braking procedure. Enter the menu by simultaneously pressing the up and down buttons, and SL1 parameters will appear. Decrease the SL1 parameters with set and arrow buttons for the bottom lock braking procedure. Use the R button to exit the menu. Now, the cooler can be set up to the SL1 parameter value. This means the set value can be lower than 26. Cooler failure codes. The cooler has various failure codes to warn the user against serious problems. These failures can be connected to the PLC with dry contact outputs or a warning system like a lamp from 220 volt output. ER1, not cooling alarm. If the cooler is consistently blowing the same temperature, and if there is no cooling even if the compressor is commissioned, an ER1 alarm will appear. There are 2 main reasons. There might be gas leakage or compressor failure. For the ER1 alarm, the gas pressure of the cooler must be checked, any leakage must be repaired, and the compressor current values must be checked. The gas pressure check is done via the service pressure relief valve in front of the compressor. The example shows a gas leakage in the system. The pressure value must be between 1.5 and 2 bars. There is gas leakage if the pressure value indicates a lower value. In this case, 15 bar nitrogen must be pumped into the system, and bridge tests must be conducted on the welding connections to determine the leakage. The detected leakage point must be repaired with oxygen welding. After the leakage repair, the nitrogen in the system is vacuumed. After the vacuum, the gas specified in the cooler tag is charged. The procedure is completed and the unit is turned on. ER2 Condenser High Temperature Alarm. ER2 alarm indicates overheating on the condenser surface. There are two main reasons. The condenser core is dusty and prevents sufficient airflow, or there is condenser fan failure. For the ER2 alarm, the condenser unit must be cleaned thoroughly and condenser fan failure must be checked. ER3 Evaporator Surface Extreme Cold Error. Reasons: A. The evaporator core is dust or there is evaporator fan failure. The power is cut and the fan cover is dismounted. The evaporator fan and the evaporator core will be visible. The fan and evaporator units are thoroughly cleaned with pressured air. The 3 sockets on the electronic card are dismounted and put back into the slot. The power input connector is checked for connection. The fan cover is closed and the maintenance is completed. ER4 Overheating Error. For overheating errors, SET and R buttons are used for entering the cooler menu and the AIN parameter is changed to 1. Then, the AST parameter in the same menu is selected and this parameter is set to the desired temperature. In the example, the alarm is set to 40 degrees. Use the R button to exit the menu. The environment is heating, and when the temperature is above 40 degrees, an ER4 error will be indicated. The environment is 40 degrees, and there is an error code on the screen. The lamp connected to the dry contact output is turned on. The cooler will continue its normal operation with ER4 error. AIN. Door is an open alarm. For the AIN alarm, make sure that the door with the switch is closed and the energy clamp is properly mounted to the door switch ends. If the alarm is indicated even if the door is closed and the connections are proper, go to the menu with the SET and R buttons. Find the IPO parameter in the menu. Change the value from 0 to 1 or 1 to 0 and save with SET. This step will change the contact ends and prevent an unnecessary alarm. Electronic card output end measurement. First, turn off the cooler power. Dismount the evaporator fan cover inside. To measure the evaporator fan output, connect the measurement tool to the second end of the double socket on the card and the fifth end of the 6-part socket. 220 volt output must be observed at these ends. To measure the compressor output, connect the measurement tool to the second end of the double socket on the card and the 6th end of the 6-part socket. 220 volt output must be observed at these ends. Failed electronic card replacement. First, turn off the cooler power. Dismount the evaporator fan cover inside. The electronic card can be seen right next to the fan. 4 sockets on the card are dismounted. The teeth holding the card are gently pushed, and the card is dismounted. The new card is removed from the package. The new card is fitted to the slot by closing the teeth to hold the card. The dismounted sockets are placed on the same slots as the new card. The fan cover is closed, and the power is supplied to complete the procedure. Cooler factory setting. First, turn off the cooler power. When no power is supplied to the cooler, press the bottom arrow and R buttons simultaneously. While pushing these buttons, the cooler will turn on, the welcome message will appear on the screen. After that, the buttons are released. The cooler will go back to factory settings. Cooler condenser maintenance. Turn off the cooler power. Easily open the front cover. The condenser unit is thoroughly cleaned with pressured air. The condenser fan right under the unit is thoroughly cleaned with pressured air. The dust accumulated around the compressor is cleaned with air. The cables are checked for any wear. The drainage hose is checked for any blockage or damage. Cooler evaporator maintenance. Turn off the cooler power. The evaporator fan cover is dismounted. The evaporator fan and the evaporator core will be visible. The fan and evaporator units are thoroughly cleaned with pressured air. The 3 sockets on the electronic card are dismounted and put back into the slot. The power input connector is checked for connection. The fan cover is closed, and the maintenance is completed. Dismounting the cooler. Evaporator fan change procedure. The cooler power is turned off and the fan cover is dismounted. The connector apparatus on the cable ends are dismounted. The fan cable with dismounted ends is pulled towards the front of the cooler. The metal holding the fan is dismounted from the screws. The dismounted fan can be easily pulled out. When the same operation is repeated backwards, the new fan is mounted to the cooler. The black phase cable from the fan is connected with the brown phase cable on the cooler and one end of the capacitor. The brown cable on the fan is connected to the other end of the capacitor. The grounding and neutral cables are separately connected. The cables are connected with the clamps, and the procedure is completed. Failed compressor replacement. As shown, the compressor current is measured with the measurement device from the phase cable. The compressor drawing current above the predetermined values is damaged and must be replaced. First, the gas in the system is discharged. electric connection of the compressor is dismounted. The riveted joints at the base are dismounted. The welding points on the compressor are removed by heating with oxygen welding. The compressor is removed with the base metal sheet. The clips under the compressor and emptied and dismounted. The new compressor is fitted to the same place with new rubber wedges and fixed with 4 clamps. The pressure relief valve dismounted from the old compressor is welded to the new compressor. The dismounted energy sockets are mounted to the same place on the new compressor and the intervention cover is fitted. The compressor is fitted with the base metal sheet. The dismounted copper pipe ends are welded to the new compressor. The dismounted energy cables are connected according to their colors. The dismounted pop rivets are fitted and the cooler body is assembled. The system is vacuumed again, and the gas specified in the tag is charged to complete the procedure.